All right, go ahead and take out your textbooks now. Turn to page 527. And as we work with this idea of squared values, there's a geometry application to this idea of squares, and something you should recall from your 7th grade days, something called the Pythagorean Theorem.
We just learned about that.
7th grade, in fact, has been spending the last couple days talking about this, but in a right triangle, it's been proven, and we're not going to take time to talk about the proof, but you can look at it there in your textbook if you want. We'll prove this a number of ways in geometry when you get to your junior year. But if you were to take the square of one leg of a right triangle, let's call it A, and if you were to take the square of the other leg of the right triangle, call that B, and add those two squared values together, it will always equal the square of the hypotenuse, which will represent C. So you should remember this formula, if you will, C squared equals A squared plus B squared. Does that look familiar? Something you learned in 7th grade? Just remember, A and B have to be the legs, and C has to be the hypotenuse. I'll usually abbreviate that HYP, just height. And we'll roll with that. It has to equal the hypotenuse. If you would, go ahead and look at the example problem there on page 527, and there's an example of a right triangle drawn there. One leg has a length of 12. We don't know 12 what, it doesn't say inches or anything, just 12 something. And then there's another leg, remember those are the sides that make up the right angle, that's 16. And the question is, how long is the hypotenuse? Well, to find the length of the hypotenuse, you go to the Pythagorean Theorem. And I always like to start by writing it out. C squared equals A squared plus B squared. And then in place of C, A, and B, we'll plug in whatever we know. Do I know the hypotenuse, class? Then I can't plug anything in for C. Otherwise I would, but I can't. We'll just write C squared. And then can I plug something in for the A? Yeah. Sure, one of the legs. You pick 12. The 12. And I think we can square it in our head, right? We don't need to write 12 squared because we're too lazy. What's 12 squared, class? 144. Plus, and if 12 is A, then Lana, B must be 16. So, but again, we're not going to write 16 squared, but maybe figure 16 squared maybe off to the side of your paper there, or see if you can do it in your head.
Can't be 256.
It is 256. Why can't it be 256? All right, it is 256. No, that is 256. And then, of course, just letting the math tell us what to do as we solve this pure quadratic equation now. We add together the values to get, 400. Good, Joshua. And that's C squared, though. Remember the pure quadratic equation, we don't want to leave it at C squared. We would want to take the square root of both sides. And, of course, the square root is C squared, class. C. And does anyone remember the square root of 400? 20. Now, technically, class, there are two square roots, right? Positive and negative 20. But is there such a thing as a negative length? No. Now, I mean, people can be short, right? But they can't ever be negative length, okay? So we're just going to say the answer is 20 units. Whatever the 12 and 16 were, that's what this is as well. Does that make sense? Let me do this. Maybe have some paper out, or maybe, how about maybe the back side of a sheet of paper or something. Let's use this corner of the chalkboard here, and I'm going to measure over, 24 inches, and I'm going to make a little mark right here. And I'm going to come up, and let's go 18 inches. I'm going to make a little mark right here. So I have a side that's 18 inches. I have a side that's 24 inches. And of course, we have a right angle here in the corner. And let's see how long this line would be that runs between these two marks. Well, if you want to find one side of a right triangle, and you already know the other two, class, you need to use the Pythagorean Theorem. So let's start by writing the Pythagorean Theorem down on your paper. Class, tell me what to write.
C squared.
And am I solving for A, B, or C here?
C.
Once again, I'm solving for the hypotenuse, so we're solving for C, so I can't plug anything in there. Now, we're going to need to square both the 18 and 24. Josh take 18, Lana take 24. What do we get when we square the lengths of the legs? All right, the 24 squared is 576, and the 18 squared, Joshua's got it. I thought he had it. 18 squared.
424.
324?
3.
It is 324. All right, 324. And now what do we need to do? Back to Joshua.
You add them.
Yeah, let's add them together, and what do we get? Lana, help. Oh, you got it. 900. And does that mean that this is 900 inches long, class?
No.
No, that's C squared. What do I need to do now, Lana?
Divide.
Not divide. How do I get rid of the squared?
Oh,
With
just
all-
take the square root.
Take the square root, same as we would for any other pure quadratic equation. And of course, the square root of C squared, class, C. And we could factor 900 pretty easily.
30. Isn't it?
Well, I was going to say it's 9 times 100, which is 3, times 10, which is 30. Yes, the square root is simply 30. So if I measure these correctly, this should come out to exactly 30 inches. And now let's see what we've got here. I'm actually going to have to turn it this way because the chalk tray kind of gets in the way. Let's see if we've got 30 inches. And there we go, right there at 30. So again, just one way in which you can solve, yeah, things like that. Turn over to page 528 now. Page 528. And look at this triangle. This time, you notice they've got the hypotenuse given. Right? The hypotenuse is listed at 17, one of the legs listed at 15, and the question is, how big is the other leg? I guess I think I actually kind of drew it backward or mirror image here. But again, this time when we go to write C squared equals A squared plus B squared, I know C. So I'm not going to leave C squared by itself, class. I'm going to write what 17 squared is. Find it.
No, it's 289.
He does it. He finds it the smart way. He looks in his book at the 289, and I can know, for instance, the 15 squared.
225.
225. There we go. And but I don't know the other leg, right? What am I going to have to do to solve this incomplete or this pure quadratic?
Subtract from both sides.
We'll subtract what?
225.
Right, this time we're going to subtract 225 from both sides. That'll give us B squared is equal, Lana, to
46.
64. Liz Dex, there we go.
So
And but I'm not done, right? That doesn't mean this is 64 units long, class.
The square root.
Take the square root, and that'll give me B is equal to 8.
Wait, why is
So apparently this is 8 units long.
it B squared? Like,
No.
Because I decided to make this A squared. They decided to make it B squared. Does it matter? No. Either leg. The leg 15, Lana, could be considered leg A or leg B. If you look in the book, they called the 15 leg B. I called it leg A. It doesn't matter. The legs are interchangeable. It's just the hypotenuse that's very, very picky. Does that make sense? Good question. Good observation there. Look over at page 530 now. Page 530. And look at number 1. You've got a right triangle there. You've got 2 legs of 3 and 4. At your seats, find the length of the hypotenuse using the Pythagorean theorem. Who discovered the relationship? It's credited to a guy named Pythagoras, which explains why it's called the Pythagorean theorem. He's a Greek mathematician, wannabe scientist. He did make some scientific discoveries. He also made some very inaccurate scientific predictions, but a great math teacher.
He's pretty smart.
Very smart. Of course, like all great mathematicians, he stood on the shoulders of those who came before him and made some important discoveries even before he did. So he built off of discoveries that other mathematicians had made.
Which ones are we doing?
Just number 1.
Oh.
Just find the length of the hypotenuse. And Joshua, what did you get? 5 units, good. Did you get 25?
Well, I forgot to reduce it.
Forgot to take the square root?
Yeah.
Don't forget to take the square root. How about number 3 at your seats? Do number 3 at
Would
your
it
seats.
be wrong to say positive and negative 5?
It would be because you can't have a negative length. So technically positive negative 5 is the square roots of 25, but when it comes to writing the length of the hypotenuse, it's got to be 5, because what would negative 5 look like? All right, number 3. Number 3, using the Pythagorean Theorem, this time to find a leg.
Oh, to find a leg.
Did you notice that? On number 3, it's not the hypotenuse. You know C. So don't say C squared equals 25 squared plus 15 squared. What goes in the C spot, class? Which one's
25.
the hypotenuse?
25.
25. How do you know which
is the
one's
hypotenuse the longest side?
the hypotenuse? Okay, this goes back to what we talked about with triangles months ago. I expected you to remember this. The hypotenuse is always across from the right angle. So if you see the little point, and imagine the point's like an arrow. Whichever side the little box points to, that arrow, that's the hypotenuse. That's your C.
Well,
Yep. All right, so go and start over on number 3 then if you started it wrongly. I think I've said it before, you're not allowed to forget anything. So things like legs and hypotenuse, you're not allowed to forget those things.
that was pretty bad.
It was only a couple months ago, Lana.
It was?
I expect you to remember your multiplication tables too. That was from years ago. It's okay, I'm giving you a hard time. Word number 3. Go ahead and put it away. You're too loud. Really good at multiplying stuff times itself with this process, aren't you? Check your answer. Did you get 20? 20 for your length. Should have squared the 25 to be 625. Should have squared the 15 to get 225 and subtract from both sides, not to get 850. That's if you put it in the A and B spot. But since this was C, you subtract to get 400, and we take the square root, you get 20 for the missing leg.
I just multiply on.
I forgot to subtract.
Careful how to multiply. All right, number 5. What are we finding? Leg or hypotenuse on 5?
Hypotenuse.
So that's which letter?
C.
You're finding C this time. Go to number 5. remember doing 24 squared earlier. I'm just going to look it back up. Smart, smart. No sense reinventing the wheel. You already figured it once. And what is the square root of 625? I feel like we just saw this a moment ago, didn't we?
Wait.
I feel like
Wait.
but I don't remember.
Oh, 2 Wait, was it 6? I did something.
No, that's something different. That's
Oh no, I did.
25.
Yeah, 20.
Remember the very last
Oh.
problem, we squared the 25 to get 625. So when we see a square root of 625, we know the number's got to be 25. And there's our answer here on number 5.
I got it like mixed up because I looked at a different.
Yeah. All right.
I looked at 900.
Look at the next page, number 7. Look at the next page, number 7. What are we finding? Leg or hypotenuse?
Leg.
Leg. So either A or B, it doesn't matter. That's what you're finding here. Tell you what we're going to do, Scott. For sake of time, I'm going to issue calculators to my students here.
Yay.
We're going to let them see if they can figure out how to use calculators. So Scott, if you have a calculator, you can go and get one out for these last few minutes of the lesson.
Oh, it's not tiny.
And you can see if you can figure out how to use it. That's always fun.
You want to switch? Sure. I don't want that.
All right, the big one scares Lana.
Because
All
it's
right.
like flashing blue.
Yeah, it's just okay. It's like a cursor on a Microsoft Word document. All right.
Oh. I've never seen that.
It's okay.
Number 7.
I'm backwards again. Do we want to call it A or B, class?
B.
B? All right, so C squared equals A squared plus B squared. What's 34 squared? Find it on the calculator.
1,156.
All right, and what's 16 squared? Hayden is faster in his head than y'all are on the calculators.
Wait, 16 squared isn't 256?
It is 256.
We just.
All right, what do we need to do now?
Subtract from both sides.
Subtract the 256 from both sides. And that'll give us B squared equals?
$800.
900.
900.
Glenn is faster in his head. All right, and we've actually seen this one already today too. When we take the square root of both sides, we get B equals 30. So there's our missing leg. Go on to number 9. Number 9. What are we finding, leg or hypotenuse?
Leg.
We're finding a leg. Do we want to call it A or B?
A.
A, just to mix it up. All right.
Wait, it's hypotenuse.
So what's the hypotenuse, Lana?
Thing every time?
What are we finding, Lana?
Oh.
Are we?
Yes.
In number 9.
Oh, I was looking at it. Whoops.
So what are we finding, Lana?
The leg.
The leg. So that means I know the hypotenuse. So in place of the C squared, I'm going to be putting 61 squared. What's that?
3,721.
3,721.
How'd you get it that fast?
You typed it on the calculator.
Nope.
And then A squared, well, that's what I'm finding. Plus, well, we all know 11 squared, class.
120.
121, right? And then what do we need to do?
Subtract 100.
Subtract away 121 from both sides, and that's going to give me A squared is equal to 3,600. And then, wait a second, we could take the square root of that without the calculator, couldn't we? 60. Yeah, 36 times 100 comes to 60. Glenn's showing off back there without the calculator.
Okay, let's go. Let's go.
And now Hayden wants a chance to show off.
Dude, I can't even keep up with this stupid
Alright, calm yourself, calm yourself. Tell you what, we are almost out of time, so we're going to have to pick up with more of this tomorrow. I'm going to modify a little bit of what, or on Monday rather, I'm going to modify the homework though.
I like this.
I'm going to do 530, pages 530 to 531, pages 530 to 531. I want you to do numbers 2 through 12, the even.
Wow.
Pages 530 to 531, do 2 through 12, the even.
Where'd you get this calculator?
I don't know. All right. And to tell you what, I'll even let you use calculators for the homework this weekend. So.
Yay! I
Yeah.
use them anyway.